One more example for the exact equation. You have the differential equation like that. Again, you got to check first whether this equation is the exact equation. M is equal to 2x minus 5y plus 3. N is equal to, see, you got to take the negative sign with you for the n, okay? Minus 5x minus 4y plus 6. You do derivative of m with y, and you do derivative of n with x. N to y equal to what? M to y equal to what? Negative 5. N to x equal to, derivative of n to x equal to negative 5. So it is equal, then it is exact equation. Now we got to find the answer for this equation. We can start with m. When you do integral with respect to x, y, you look at it as a constant. What you get for the first term? Integral to x dx is equal to x squared. Integral dx equal to x. So you would get negative 5xy plus 3x plus dy. If we find dy, then you would know what is the fxy. So the way to find dy, you got to do from df by dy equal to n. And now we know our n is equal to negative 5x, negative 4y, and plus 6. And we know that our f is equal to x squared minus 5xy plus 3x plus dy. So you do derivative of x to y, then it will be equal to this term, right? Now, derivative of x to the y is equal to what? The first term equal to, you do derivative of x to y, the first term equal to 0. The second term you would get what? Negative minus, or negative the same meaning, minus 5x. The third term, 0, and plus dy, derivative of g function. Okay, and then you just plug this one back in there, negative 5x plus dy. You see, you have negative 5x this side, and this side you also have the same thing. So they all cancelled out, right? Now you would end up with derivative of function y equal to minus 4y plus 6. So this term we can write it down again in this form. And then we can find dy by doing the integral. Right? Both sides, you would get dy is equal to what? This one is integral minus 4y dy plus integral 6 dy. The first term, what you get when you do integral? Negative minus 2 times y squared. And the second term, what you get? Plus 6y. Then you plug it back in here, you would get fxy, right? So we would say fxy equal to x squared minus 5xy plus 3x minus 2y squared plus 6y equal to c. That's the answer. Again, if you don't want to do this way, you can do integral for both the term of n and m, and then you do union. You would end up the same. Okay, do the other way. Or whenever I do the second technique, I always put the x there, because this one is just showing that we integral it compared to the x. So you would see the x term, all of the function of x. Our m is equal to 2x minus 5y plus 3. Again, because we do integral compared to x, y we will get it as a constant. That's why I can take y out of the integral sign. The first term, what you get? X squared. The second term, minus 5xy. And the third term is plus 3x. When I do this way, I will not put dy, because I know that if I do integral again, I would get dy from the other function. So that's why doing this technique, you don't need to put dy there. Now we put n there, it's equal to negative 5x, negative 4y plus 6 dy. Okay, the first term, what we got? Minus 5xy, and the second term, and yep, and then we do union. Okay, what we get for the union thing? Yep, that is the answer. Any question?